Hi there, this side Viren. So today we're trying to discuss one of the question and it is from Greek for Greece daily practice question and the name of question is smallest number with sum of digit has n and it is divisible by 10 to the power n. So the clear idea of this question is already described this question name itself, and then also we are going through the test cases so we can get better understanding. And let us read what is the question statement is here given. Find the smallest number such that sum of digit is n. This is the first condition, and second is and it is divisible by 10 to the power n, and these two conditions are concatenated with and. So for that we need to fulfill both of them, right? So let me take you to the whiteboard so we get clear idea. So what is given here? First we need to minimize our number. Whatever number we build, we have to minimize that number. And what is second condition? That number, let's say that number is x, so this x is perfectly divisible by 10 to the power n, right? N is given in the question, n is given, right? So this is what the upper scenario of this question is seen like. We will discuss its scenario, we will get clear idea what they are trying to say. Let us go through one of the test cases. For example, here n is equal to 5, right? So let us discuss this test case only. So for example, n is given as 5, right? So what is our first condition? Firstly we need to build a number, let's say x, which is minimum, as much as minimum it can, but is sum of digit of this x give us, for example, let's say it have 5 digit number. So this we get sum which is equal to 5. We need to notice this. If it's 2 digit also, then also its sum becomes 5. This is the required condition, right? And we need to minimize our answer. So let us try to take you okay, let me try to take you to the dry run to minimization. Let's say n is equal to 5. The what are the possible cases? For example, let's say we are placing all the digit has 1, right? 1 1 1 1 and 1. Okay, its sum is also 5, and this is the first number. Let me build second number. What we can do, we just combine these two things and we get 2, then 1, then 1, then 1. Again its sum is 5, right? So again we are fulfilling the condition, right? Let us go through again forward. Let we combine these two number. What we get? We get 3 1 1. Again its sum is 5. Again we are on the track, there is no problem. Let me build one more number, that is, let me combine these two numbers this time, then it's become 32. Its sum is also 5. And now what is the condition left? Let me build one more number. So 5 itself, right? It is, so whose sum is 5, one digit number. So what observation we are getting from this? For getting a minimum number, we need to minimize the number of digit. What we get? We need to minimize number of digit in a number, right? So that number is minimum. From this observation only we get to know that. Let's just say here we put 5 1, the number is quite huge. And again here you can see we just reduce two digit into one digit, and you can see the difference. It is quite smaller than this two. It's like difference of thousands is there, right? And you see that 311, then you see 32, then its number become 5, and which is the quite smallest than this number. Just compare first and fifth number. We will see the lots of difference between these two numbers. It is just 5 and this is 11,000, right? So yeah, first observation, what we need to minimize the number of digit in a number. What is the first observation? In number, in x, let's say that number is x. Okay, and what is the second condition? Second condition is that x is perfectly divisible by 10 to the power n, right? So here n is equal to 5. So here n is equal to 5. So number what is the minimum number we build 5, and we need to fulfill this condition also, and then also that number become the smallest number as much as possible. So what we can do? For example, let me take one. If we want to divisible any number with 100, then what we can do? First smallest number is 100 itself, second is 200, third is 300. These all are divisible by 100, right? What is common in that? The two zeros, last two zero. Here we can rewrite this 100 into 10 to the power 2. So we just focus on these two. Number of zeros in every number is at least this, is equal to this number, right? So let's say for example n is equal to 3, n is equal to 3, right? And we need to build a number which is divisible by 10 to the power 3. So what are the possible number? 1000 itself, because it also contains 30. Then 2000, it also contains 30. 3000, it also. So from this observation, what we concluded, that if we want to build a number which is divisible by 10 to the power n, so we simply need to add n zeros, right? N zeros. Okay, this is the second observation. So let me take you through the one more example, and we try to, let's say example number 3, and we try to build the entire answer which is as much as possible. So let me take you to this test case only. Here it is given 20, right? Here n is given 20. Okay, so we need to build a number. First condition is to minimize the number. And for minimization, what we observe, we observe. Okay, and what is the second condition? That number, that's an x is divisible by 10 to the power 20. So for this, what observation we get? For this we get an observation, we just simply need to add t0 at the end, right? So yeah, let me try to build that number. So firstly, number is n is equal to 20, and we need to build a number whose sum is 20, right? So let me take, like for example, let's say 8, this 16, then 4. Its sum is 20, right? And there is no effect of adding 0 to its sum, right? We just simply add 20 0 likewise, because adding zeros, there is no effect in that summation. Its sum is also still 20, right? What else we can do? We just put, like for example, let's say what is the maximum possibility of any digit? It's vary from 0 to 9. Okay, and we need to minimize this as many as digit we can. So what we can do, for this particular digit I can maximum take 9. So let me take 9 here. Now if we take 9, then 20 minus 9, it's 11. Then we need 11 for this many places. What I can do, I just put one more 9. Now what I need only 2, so I just put 2. Just see the difference between these two number. This is 884 and this is 299. So yeah, we can conclude that this is the smallest number we get. So let me try to fulfill second requirement. What is our second requirement? Second requirement is the number, this x is divisible by 10 to the power 20. So we simply need 20 zeros in, like this, 299. Let me move it upward. Okay, 299, and we simply need 20 times, right? So this is our number. Let me take you to the coding part, and if we find to discuss anything, so we will discuss here. Okay. So firstly, what should I do? Try to remove as much as 9 I can do. So for that, for example, say, let me discuss that part only. For here we have 20. So how many maximum 9 we can extract from this 20? So simply divide 20 by 9. So we get 2 point something, and we just take interested in the integer part. So answer is 2. So maximum 29 we can extract from this 20, right? So maximum 2, as we saw also 299 number we built, 299. So this 29 we built. Now what we do? Now we in temporary variable, let's say temp is equal to number itself minus number of 9. That's a count of 9 into 9. This we subtract, and we get, like for example, 20 minus 2 into 9. So here we get 2, right? So we just simply concatenate this 2 with 2, this 2 with 2 nines. So number become temp plus count of 9. How many count? 2 times 9. 9 plus 9. This is our number. And after that we simply concatenate with zeros. The number of zeros is equal to n, right? So yeah. So for that, let me find the number of count of 9s, right? Is equal to n by 9, because okay, and in temporary variable let's say count of temp is equal to original number minus count of 9. Okay, right? Now let me take one empty string, let's say answer. Okay, and here I need to check one thing, like if temp count of temp is not equal to 0, then what should I do? I just simply add answer plus is equal to, if it's 0 then I will not do anything with answer and I simply go through. Let me discuss this why I am adding this count of temp is not equal to 9. Let's say our n is equal to 81, n is equal to 81. Okay, so we need to build a number whose sum is 81 and which is divisible by 10 to the power 81, right? This is our requirement. So let me build that number. So what are the possible cases? How many 9 we can build? 81 divided by 9, so we get 9 times 9s, right? And this is our count of 9, right? And what we are storing in our temp, we are storing our temp is 81 minus 9 into 9, which is 0. So there is no sense of adding 0 in front. Let me Okay, so there is no sense of adding 0 in front of number. Let's say this time 1 2 3 4 5 6 7 8 9, this 9 is fine. There is no need to add this 0 in front of this number, right? There is no sense. So for that why I am checking that if it's not 0, if it's not 0, then yeah, we good to go and add. For example, count of temp is equal to 2, which is in we saw in previous case. So simply add this answer plus is equal to 2. There is no excuse here, right? So if it's 0, there is no need. It's not 0, then we add simply. Then now it's time to add 9. So we run this for loop for count of 9 times and we simply add 9 here. Okay, and we can't add like this. We firstly need to convert into to string. Okay, okay, fine. So we add that temporary required sum and we add this many 9s, and now it's time to add n times 0. This many time we add 0 and simply return answer. Okay, let me see if it's fine to submit, otherwise we can bug it out if there any bug is there. Compilation error, it's showing that count of 9. Okay, here it's count of 9 not 0. Yeah, it's fine. Let me submit. It got submitted. So thank you for watching.